Good morning, dear students. My name is Ferhan Mazher, and today is 26th of January 2022. Right now, I am with the ninth Cambridge class, and the subject we are studying is D Maths 4024. Today, we are working on the syllabus, and we have selected exercise 10A. This is from the book D3. The name of the book is New Syllabus Mathematics 7th edition. This chapter is about arc length, area of the sector, and the radian measure. Today we are going to solve exercise 10A. It's question number 16 to question number 21. So let's start today's exercise. And okay, so let's go to the exercise. So this is D3 exercise 10A, and we will be working from the question number 16. So the question number 16 is coming up on your screen. He says in the figure, O is the center of a circle of radius 7.5 centimeter. The point A and B lie on the circumference of the circle, and the OBP is a straight line. So OBP, this OBP is a straight line. This is a circle, center O, its radius is 7.5 centimeter. This PA is 14 centimeter. This area is shaded. Given that PA is equal to 14 centimeter and OA is perpendicular to AP, find the angle POA. So we have to find out the POA. I want to find out this angle. It's a right angle triangle. And I want to know this angle O, POA. And then second part is find the perimeter of the shaded region, PBA. So we want to find out this shaded region, and we want to find out the perimeter of this shaded region. So let's go to the solution. Okay. So today we are working on exercise 10A, question number 16 to question number 21. So you can see that this is that triangle OPA. OPA triangle is a right angle triangle. This AP is 14 centimeter. This OA, which is the radius, that's 7.5 centimeter. And we want to know this angle. So if I will take this angle, then this will be my base, and opposite to that, this will be my perpendicular. So the ratio between the perpendicular and the base is tan. So I will use tan. Tan POA, this angle, which I don't know, I want to know it, is equals to the perpendicular by base. That will be 14 by 7.5. So bring this tan to this side, it will become tan inverse. It will become tan inverse. And so POA will be equals to tan inverse 14 by 7.5. And you will have POA will be equal to, in your calculator, you will enter shift tan, bracket start, 14 divided by 7.5, bracket close, equals to, and that will be 61.8. So the angle POA will be 61.8 degrees. So this is how you do this. And the next question they asked us is find the perimeter of the shaded region. So if you look at that diagram, let me show you that diagram. If you want to know the perimeter of this shaded region, I need to know PB, and this side, this is the perimeter. This is one of the sides of that shaded region. That's 14, and this arc. So once I know this angle, I can find this arc, and the formula for the arc is theta by 360, 2 pi r. I will find this arc. Then I will, on this right angle triangle, I will apply the Pythagoras theorem, and I will find the PO side. Once I know the PO side, from that PO side, I will subtract the OB, which is the radius, which is 7.5. I will get this PB, which is the one of the sides of the shaded region. So then I will add PB, PA, and this arc, and that will be the shaded and the perimeter of the shaded region. So let's go. Let's see how we can solve it. Okay. So first of all, I'm going to. The perimeter of the shaded region is the question. So I will apply the Pythagoras on that triangle, on this triangle basically, and I will try to find out what is the length OP. So OP is equal to PA square plus AO square. Hypotenuse square is equal to perpendicular square plus base square. So OP square will be equals to the 14 square plus 7.5 square, and that will be 252.25. Take square root on both the sides. So you will have 15.9 centimeter. OP is 15.9 centimeter. From OP, I can find the PB, and the PB is OP minus BO. BO is the radius, and so 15.9 minus 7.5, and it will be 8.38. Then I will find the arc. The arc, the arc, the formula for the arc of the sector is theta by 362 pi r. Theta is 61.8 degrees, divided by 360, multiply 2, multiply pi, multiply 7.5. The radius is 7.5, equals to, and that will be 8.1 centimeter. So now I know the sides of that shear region. The perimeter of the shear region will be PA plus the arc plus the PB. PA is 14 centimeter, arc is 8.1 centimeter, and the PB side is 8.38 centimeter. So if you add them, that will be 30.48 centimeter, which is 30.5 centimeter. So this is how you will do question number 16. I hope that it makes sense to you. Okay, so let's go to the next question. So question number 17 is showing up on your screen, and I can show you the whole question. I think, yeah, this is. The figure shows a circle with the center O and radius 26 centimeter. You can see here, this radius is 26, this radius is also 26. Triangle OPR. OPR, this triangle, and you know this tangent and the radius, they makes 90-degree angle. If you are in class 9th Cambridge, you might have not yet studied the chapter 13 of the D3, which is about the circle properties. And in that, when you will study that chapter, you will know that the tangent and the radius at the point of tangency, they make 90-degree angle with each other. So it has already been mentioned here that this angle is 90 degree because this is tangent and this is radius, so the angle between them is 90. Triangle OPR and the OQR are congruent. So these two triangles, OPR and the OQR, they both are congruent. They are exactly the same triangles, and the angle OPR and the angle OQR, they both are of the 90 degree because the tangent makes 90-degree angle with the radius. Given that the angle POQ is 138, this whole angle is 138 because both these triangles are same. So the half the angle is here, the half the angle is here. So this dotted line basically bisects this 138 angle. So I can tell how much angle is here, how much angle is here. Just simply divide 138 with the 2. Then it will be a right angle triangle and you can play with it. The length QR, they want us to find the length QR because both these triangles are congruent. So this is 26 centimeter. This side is also 26 centimeter. This is the radius, this is the radius. The both radius are 26 centimeter. And this angle, this will be half of the 138. And then it's a right angle triangle. I know the base because this side is with this angle. So this is the base. And I want to know QR. So that's the perpendicular. So I can apply the tan theta, the trigonometric ratio tan theta, and we can find the QR very easily. Then the second part is the perimeter of the shear region. If you want to know the shear region, okay, so we will have to find this length, and the QR side and the PR side, they are the boundaries of that shear region, plus this arc. So I can find the length of this arc very easily. If I know this angle is 138, I will apply theta by 362 pi r. The radius is 26 and theta is 138. So I will find this arc plus the QR plus the RP, and that will be the perimeter of the shear region. Hopefully you understand the logic which and the strategy which I'm giving to you. Okay, so let me show you how this is done, and let's hope you can understand. So first of all, I have shown that that triangle. So RQO, the angle here, that total angle was 138. When you divided it with the 2, so it will become 69. So this angle is 69. This is the radius, and because it's with this angle, so this adjacent to this angle, so this is base. And this QR side, which is opposite to the given angle, that is your perpendicular. So I will use the tan tan, trigonometric ratio tan 69 is equals to the perpendicular divided by the base. So when I will make this RQ alone, this 26 will go on the other side. It will multiply with the tan 69. So the RQ will be equals to 26 multiplied tan 69. RQ will be equals to, when you enter these values in your calculator, you write 26 multiplied tan 69 equals to, and that calculator will give you the answer 67.7 centimeter. So now I know the QR. That's 67 centimeters. Okay. Now the question is the perimeter of the shear region. I told you that we have to find out, if you want to find the perimeter of the shear region, perimeter means the outer boundaries of that shear region. So the outer boundaries are the two tangents there, both are equal to each other, and both of them are 67.7. And the arc, we have to find out the arc. The formula for the arc is theta by 362 pi r. Theta is 138 divided by 360 multiplied 2 pi, and the radius is 26. When you enter these values in your calculator, you get 62.6 centimeter. So the perimeter of the shear region will be QR plus RP plus the arc. So 67.7 plus 67.7 plus 62.6, and that will be 198 centimeter. 198 centimeter. So this is how you will do question number 17, and I hope that it makes some sense to you. Okay, so let's move to the next thing. Okay, so let's have a look at the next question. Okay, so this is the next question coming up on your screen. That is question number 18. He says the figure shows a sector of a circle with the center O and radius 13 centimeter. Given that the length of the chord AB is equals to 22 centimeter, show that the angle AOB is approximately 115.6 degrees. That's the first question. We have to show that this angle AOB, this angle is 115.6. And the second question is find the perimeter of the shaded region. This is the shaded region, this shaded region. So I want to find out the perimeter. So the perimeter is this arc and this straight line, which is the chord, and we already know what the length of this chord. So because this is radius, that's 13 centimeter. This is also radius, which is 13 centimeter. So it's kind of isosceles triangle. This side is 22 centimeter. If I draw an altitude here, so that will divide this chord into two equal parts, and 11 centimeter, 11 centimeter, and the angle between this chord and the line segment coming from the center will be of the 90 degree. I think you have not studied it yet. This is in chapter number 13, D3, New Syllabus Mathematics 7th edition, properties of circles. So I hope you will be able to understand. Let's go to the next solution. So question number 18, first part, this is isosceles triangle. 13 centimeters the radius, so this radius will be also 13 centimeter. This side is 22 centimeter. So this is the chord from the center, the line which comes on the chord and makes 90 degree angle with the chord bisects that chord. So this chord will be bisected. So this portion will be 11 centimeter. This portion will be 11 centimeter, and the angle here will be 90. So this is a right angle triangle, and if I take this angle, then this will be my perpendicular, and some people call it opposite side. And this will be the hypotenuse. 13 is the hypotenuse. So I can find this. The ratio, the trigonometric ratio of the perpendicular and the hypotenuse is known as sine theta. So sine theta is equals to perpendicular by hypotenuse. So sine theta is equals to 11 by 13. Theta will be equals to sine inverse bracket 11 by 13 bracket close. In your calculator, you will write shift sine bracket start 11 divide 13 bracket close equals to, and your calculator will tell you 57.8 degrees. So I know this portion of the angle, that's 57.8. So double it, you will get the whole angle, this whole angle, and that will be 115.6 degrees. So that was the question A or B. Hopefully you understand question number 18, first part. Okay, now we go to the perimeter of the shear region. And I told you the perimeter of the shear region is there is an arc and there is a chord. And we already know that the chord is 22 centimeter long, and the arc I can find out. The formula for the arc is theta by 362 pi r. Theta is 115.6 divided by 360 multiply 2 multiply pi multiply 13. Radius is 13. equals to, and you will get 26.2 centimeters. So the length of the arc is 26.2 centimeters. The parameter of the shaded region is AB, that chord, plus the arc. So the AB side is 22 and the arc is 26.2. So the total parameter of the shaded region will be 48.2 centimeter. 48.2 centimeter will be the parameter of the shaded region. So this is question number 18, and I hope that it makes some sense to you. Okay, so question number 18 is done. So let's move to the next question. Question number 19, listen carefully. This might a little be confusing. In the figure ABD, they're talking about this A, B, and D is the minor arc of a circle with the center O. The AB is minor arc and the center is O, and this OA is the radius, OD is the radius, O with the center O and the radius 9 centimeters. So the OD thing is 9, OA is also 9. ACD is the minor arc of a circle with the center P and the radius 16 centimeter. This ACD, that's the arc of a circle whose radius is at P and whose radius is basically PA and PD. PD is 16 centimeter, PA is also 16 centimeter. The point X lies on the AP. On AP, we have a point X such that it has bisected that the chord AP. So if a point is cutting the chord, bisecting the chord, so when you join it with the center, this red dotted line will make 90-degree angle with this. Okay. So the first question they are asking is you is to find the angle APB. They want you to find A, P, and B. If you join P, A, and B with each other, it will be a right angle triangle. And I think you have not yet studied that chapter, circle properties, chapter number 13, D3. We know that if I take the ends of a diameter and I take them to the circumference, the angle formed at the circumference will be of the 90 degree. So at the A, when you join A and B, so this AB, that angle will be 90. And I know that this side is 16, and I know that this radius is 9, and this radius is 9. So this whole thing, BP will be 18. B to P, this is radius, and this is 9, this is 9, so it will be 18 total, and the AP side will be 16. So very easily I can find the angle APB. Then they ask you to find out the angle AOB, and very easily I can find, if I know this angle, I find on this angle, its double angle will be here, and then I will double it, so I will get the AO. So sorry, this angle AOB will be the double of this angle. So very easily I can tell that. Then they will ask you to find the parameter of the shaded region. The parameter, the shaded region is here. I don't think that is very clear to you, but this is the shaded region. If you have the real book with you, then you will know that this is the shaded region. So this shaded region is bounded by two arcs. This arc ABD, its center is O, radius is 9, angle at the center I know if I double this angle. ACB is also an arc of the sector, and its radius is 16 centimeter. Its center is at P, and its radius is 16 centimeter. So very easily I can tell what is the. I can very easily tell what is the all these three things. And let's go to the paper where I have solved it. Okay, so here we go. APB. And that is that thing. BB is the diameter, the radius is 9, so BP is diameter, so that's 18. PA is the radius, and that's 16. There are two arcs, okay, so both of them have different radius. So its radius is 16, and I want to know this angle. I know this angle here will be 90, because this is the diameter. When you take the ends of the diameter to the circumference, the angle formed is of 90 degree. That's the circle property from the chapter number 13 of the D3, which you have not yet studied. So the cos APB will be equals to, I know this angle, I know this angle, I want to know this, I know this side, I know this side, I want to know this angle. This is your base, this is your hypotenuse. The ratio between the base and the hypotenuse is known as the cos. So the cos APB will be equal to 16 by 18. Cos is base by hypotenuse. So the APB will be equal to cos inverse 16 by 18. So in your calculator, you will write shift cos bracket start 16 divided 18 bracket close equals to, you will get 27.3. So this angle here is 27.3. The angle AOB, that's the property of the circles, that the angle subtended at the circumference and the angle subtended at the center by the same chord. So the angle AOB, the angle subtended at the center, is 2 times the angle subtended at the circumference. So the angle AOB will be equals to 2 times the angle APB. So 2 multiply APB is 27.3 degrees. So 2 multiply 27.3 degrees, and that will be 54.6 degrees. So once I know that second part, the last thing is they want you to find out the parameter of the shear region. I told you that the parameter of the shear region are 2 arcs. There are 2 arcs which are bound around that shear region, and one of the arcs is its angle is 109. Its radius is 9. The other arc is angle is 54.6, and its radius is 16. The formula for the arc is theta by 362 pi r. Just enter the values for arc 1 and arc 2. For arc 1, I will write 109 divided by 360 multiply 2 multiply pi multiply 9. And for the arc number 2, I will enter 54.6 divided by 360 multiply 2 multiply pi multiply 16. So when you enter both these values in the calculator, and you will get the answer 32.4 centimeters. So this is how you will find the parameter of the shear region. I hope that this makes sense to you. So let's go to the next part. So here we go. This is question number 20, and this is advanced level, okay, of this exercise. In the figure, O is the center of a circle. The points A and B lie on the circumference of the circle, such that the AB is 15 by 2 multiply under root 3 centimeter, and the angle OAB is 30 degrees. So I know this angle OAB. I know this angle because this is radius. So this angle will be also 30 because it will be isosceles triangle. A triangle whose 2 sides are equal. It is isosceles triangle, and the angles opposite to the internal angles opposite to the equal sides will also be equal to each other. This is isosceles. So if the OA and OB are equal sides, so the angle, this angle is 30, so this angle here will be also 30. So I can very easily find out this angle, and that angle will be 180 minus 30, and I think that will be 120. So once you know this angle, you know this segment is shaded, this whole segment is shaded, but it's a major segment, so its angle will be here. So you can find this angle here, 360 minus 120. So that will give you the you can find then the arc of this major sector, and you can find this length, and this length is already given. The question is find the parameter of the shear region. The parameter of the shear region is this arc and this straight chord. So the chord's length is already given. Once I know this angle, I can find this arc also of the major sector. It's a very easy question. Let's go to the my solution. Okay, so here we go. So here this is radius, here we have O, and this has been divided into equal parts. This is an isosceles triangle, so this is 30, this is 30, so this angle will be 120. So I can find out the radius very simply. I will, because this is isosceles triangle, and this line which comes from the center to the chord makes 90-degree angle. It bisects the chord. So this whole chord was basically 15 under root 3 divided by 2. So if when you divide with the 2, so this will be 15 whole under root 3 divided by 4. When you divide that thing with the 2, you get it 15 under root 3, the whole thing divided by 4. So I can apply this formula here. I want to know what is the radius, that is hypotenuse here, and the angle we are using is this one. So this will be my base. So base by hypotenuse will be cos. So I will use cos 30 is equals to base by hypotenuse, and base is 15 whole under root 3 by 4, and it will be the OA. So OA will be equals to 15 under root 3 divided by 4 divided by cos 30 equals to, and that will be 7.5 centimeters. So I know the radius is 7.4 centimeter. So now you want to find out the perimeter of the shaded region. Perimeter of the shaded region. That shaded region is basically the major segment, and that major segment, its perimeter will be the arc of the major segment plus that chord AB. So the arc will be the angle subtended by the major segment at the center. That will be 240 divided by 360 multiply 2 multiply pi multiply r plus the chord length, that is AB. So you, in your calculator, you will enter 240 divided by 360 multiply 2 multiply pi multiply 7.5 plus 15 multiply under root 3 divided 2 equals to, and that will be 14.4 centimeters. So this is how you will find the perimeter of the shaded region. So I think this will make sense to you. It's a little tricky questions. I hope you will be able to understand. So here we go. The figure shows a semicircle with the center O and diameter SR. So this is semicircle, its diameter is SR. And he says the QR is an arc of another circle. The QR is an arc of another circle with the center T. Its center is here, and T lies on the RS produced. If you produce RS, it is like this. Given that the TO, that from T to O, it is 14 centimeter, and from OTP angle, that's 36. This angle is basically 36, and the OP is perpendicular to PT. OP is perpendicular to PT. Find the perimeter of the shaded region. The shaded region is here. This is the shaded region, which is not very clear in this file, but this is basically the. If you have the book, then it will be very easy for you. So I think that this shaded region, if you have the original book with you, you will be able to see from your book. But this thing is shaded. Its perimeter will be this arc. I can tell this arc very easily. I know this angle. Once I know this radius, I can tell how much is this arc. Then I can, if I know this angle, I know this angle, I can tell how much is this arc, and I can also tell how much is this PQ length. So let me show you how this is done. Given that the TO is equals to 14 centimeter, the OTP is 36 degrees, and the OP is perpendicular to the PT, find the perimeter of the shaded region. So the shaded region is this one. Okay. So let's go to my solution. So first of all, I have taken this triangle. This side is 14. This is the radius of that semicircle. OP, and angle this here is 30 equals to sine of 36 will be equals to the perpendicular, that is OP divided by the hypotenuse, and that will be OP will be equals to 14 multiplied sine 36, and that will be 8.2 centimeter. So this radius is 8.2 centimeter. So this radius I know is let me show you from here. This radius I know is 8.2 centimeter. So once I know this radius, I can tell how much is this, the whole thing. This is 14, this is 8.2, because this is that radius of the semicircle. So this whole thing will become 22.8.2. So this will become 22. This will be also 8.2. This is also 8.2. So let me show you. Okay. So the POT, so the radius here of that semicircle is 8.2 centimeter. And in the same way, I can find out the PT. So you see here, I'm trying to find out the PT. The PT will be equals to the cos of 36. That will be the base by hypotenuse, that PT by 14. So PT is equals to 14 multiply cos 36, and that will be 11.33. So now I know how much is the PT, that is 11.33 centimeter. Now I can find the, the POT, the angle POT. I can find this angle POT. This angle will be 180 minus 90 minus 36, and that will be 54. Once I know this angle, then I can find this angle, the angle here. Let me show you from that diagram. Once I know this angle, I can find this angle, and that will be 180 minus this angle. Okay. So I'm going to do this. So I know that 180 minus 54, that will be 126. So the TR from T to R will be TO plus OR. T to TR. The TR, this whole thing, TR will be this plus this. It is 14 and this is 8.2. So that TR will be 22.2. Let me show you. So the TR will be TO plus OR, that's 14 plus 8.2, and that will be 22.2 centimeter. Now the TQ thing, the TQ, this TQ will be also same 22. If I know this TP from the TQ, subtract the TP and you will get the PQ. From this whole dimension, subtract this portion, you will get the TQ. Let me show you. So that PQ will be equals to 22.2 minus 11.3, because this portion is 11.3. So you will have 10.8. So now I can find the perimeter. The perimeter of the shaded region is arc 1 plus arc 2 plus the PQ. And the arc number 1, which is the portion of the semicircle, that will be 126 divided by 360 into 2 into pi, and its radius is 8.2, plus the arc number 2 is its angle at the center is 36, and the divided by 360 multiply 2 multiply pi multiply 22.2, its radius is 22.2. And then you have plus 10.8, the PQ, that is the straight line around that shaded region. So you will have in your calculator, when you will enter these values, you will get 31.98 plus 10.8. That will be round off. You round it off, and that will be 32 centimeter plus 10.8. So it will be 42.8 centimeter, and that will be 43 centimeter. So we are done with this, and these are the last question of the exercise 10A. So my dear students, today we have completed the exercise, the exercise. So we were working on D3, New Syllabus Mathematics 7th edition. It's exercise 10A, and we have done, I think, 3 lessons on this exercise. And all these 3 lessons have been recorded and uploaded in my YouTube channel, and you can watch them. I have tried my best to explain you the concepts how these questions are done. I hope that this video will help you to understand the concepts of this exercise. If you think that this video is helpful to you, and this can help you, your friends, your class fellows, your cousins, your juniors in O levels, your seniors in O levels, do share the link of this video with your friends, because this will help me promote my channel. Don't forget to subscribe to my channel and like this video. Thank you very much, everybody. Have a good day. God bless.